In this video, I'll be discussing the partition function from the canonical ensemble and how it relates to energy. So this is a topic from statistical mechanics. I'll begin by just writing out the partition function, being the sum of Boltzmann factors. And I'll also have here the common formula for the expectation of the energy, that being the negative derivative of the log of the partition function with respect to beta, where beta is 1 over kBt. So I think that this is a pretty common equation to learn, or formula to learn about the expected energy and how it relates to the partition function. But I don't think that the right-hand side is too intuitive as far as why it actually makes sense. So in this video, I'll be trying to make it more understandable. And the first step in doing so will be to substitute in the form of the partition function that I had written above. So here we are differentiating the log of some argument, and I'll just follow the common form of taking 1 over the argument and then differentiating the argument itself. So you'll note here that the denominator of our fraction is just the partition function. So I'll make that substitution in and also swap the order of the summation and the derivative. And now we'll just differentiate an exponential and pull down a negative e sub I, and then rearrange some terms. So we see that we have a Boltzmann factor over a partition function, which is just by the Boltzmann distribution, the probability of being in a state with energy E sub I. So in the end, we've arrived at a sum of the energy of state I times the probability of being in a state I, and we're summing over all states I. And that is just what the expectation of the energy is. So I hope that this helps explain why the formula for the expectation of the energy actually does make sense. Thank you very much for watching, and if you have any questions, comments, or suggestions, please leave them below. Thanks.